The world's coldest continent is also one of the most mysterious places on Earth. It's as unique as it is secretive, and unlike most destinations, you can't just hop off a commercial flight. Unless you're an elite scientist or an emperor penguin, exploring the Antarctic is forbidden. Even if you could, good luck overcoming frostbite-inducing temperatures of -130 degrees Fahrenheit or -90 degrees Celsius. But why is it restricted? And where did these rules come from? Grab your mittens and let's find out. Before the mid-1900s, we knew almost nothing about Antarctica. Then, an American Navy explorer by the name of Admiral Richard Byrd Jr. changed everything. Oh, and before you go asking Santa for presents, the Antarctic is actually at the South Pole. Antarctica equals south, Arctic equals north. Comprende? Anyway, what was Byrd's deal? Aside from enormous expanses of ice, endemic wildlife, and wintry conditions he'd never before seen, what else exactly did he find? While it's still shrouded in mystery, many think that Byrd came across an underground civilization called Agartha. Here, check it out. In 1957 and 58, a bunch of countries came together and were like, you know what, we love what this new research is showing and we need to protect Antarctica. So, the Antarctica Treaty was created. What does that mean exactly? Well, it means that smarty-pants scientists in lab coats can venture into the icy abyss for research purposes. For the rest of us, there are exceptions, of course. We can, for example, head to the Antarctic waters on a cruise ship. Can we set foot on the land as well? Technically, yes. There are a few landing spots along the peninsula, but compared to the entire continent's mass, it isn't even a sliver. The treaty also stated that no single nation could own Antarctica. It's divided up into partial ownership for these 7 countries. Here, check it out. So we know we're not allowed to wander around the frostbitten land of Antarctica, but why exactly is that? First and foremost, it's for the protection of the environment. It makes sense, too. The world's southern tip is a place overflowing with biodiversity. There's endemic species, underground mountains, yeah, you heard that right, blood-red waterfalls, and even gold-spewing volcanoes. But as much as we do want to keep our beloved environment thriving, we've also been banned for our own safety. Temperatures can drop to a whopping -130 degrees Fahrenheit, that's -90 Celsius. For most of us, protecting the environment and ourselves is the whole story. However, for a select few, it's believed that there's some rather shady stuff going on behind that ice wall. As you can see, it's completely visible on Google Maps satellite view, so if something shady was going on, it must be rather well hidden. Perhaps this giant alien face-like structure could be a sign of the unknown? We won't delve too deep into other theories, but they do include a supposed hidden fortress used in World War II, claims that an ancient civilization once lived down there, and of course the idea that it's the gateway to the end of the world because the world is flat. Yeah, right. Okay, so what would actually happen if we did try to visit Antarctica? If you break the rules, get ready to deal with fines of up to $10,000 US. And even a year behind bars for each rule that you break. There are a heap of rules to follow, but they mostly revolve around protecting native wildlife. But wait, since nobody technically governs the area, who's actually going to punish us? Well, it depends on where you're from. According to the Antarctic Treaty, anybody accused of a crime in Antarctica is subject to punishment by their own country. But what if you're just visiting as a tourist from a country that isn't part of the treaty? Well, in that case, usually the host nation of the ship or plane you arrived on takes the reins, and the captain or pilot of the ship could take full temporary control over you. Antarctica isn't only a restricted landmass, but also one of the largest forbidden airspaces on the planet. It's because of legislation that was introduced in the 80s under the Reagan administration. A law was created that stated no aircraft, regardless of where they are, is allowed to be more than 60 minutes from an airfield in case of an emergency. Since the infrastructure around the South Pole is next to none, we have to avoid it in the name of safety. Of course, that rule usually only affects commercial jets. Chartered jets can still come and go to bring staff to the research bases, which hovers around 3,000 in the summer and 400 in the winter. While it can become rather bleak and boring, there are still a few basic facilities.
Icebergs all the time. Some are small, some are immense. Some drift into the Southern Ocean and become temporary landmarks of climate headlines before vanishing into melt and fracture. But this one, A tabular iceberg named A84, roughly the size of Chicago, did something far more important than simply break loose. It removed a ceiling. It exposed a piece of seafloor that had been hidden beneath the George VI ice shelf and inaccessible to humans until that moment. And when scientists reached that newly uncovered patch of Antarctica's seafloor just 12 days later, they found something that changed the emotional meaning of the event completely. They did not find a barren wasteland. They did not find empty mud waiting under the ice. They found a living ecosystem, sponges, corals, anemones, large animals, and structured communities on a seabed that had been covered by floating glacier ice for a very long time. Schmidt Ocean Institute said the team became the first to investigate that area after A84 calved, and their early observations showed a thriving ecosystem with organisms large enough to imply decades, perhaps even centuries, of biological persistence beneath the ice. Cambridge's summary of the same expedition emphasized vibrant communities of ancient sponges and corals in a place that had never before been accessible to human study. That is what makes this story so powerful, because the iceberg did not just break away from Antarctica, it opened a window into a hidden world. And what that world revealed is one of the most important lessons in modern polar science. Even beneath ice shelves, even in darkness, even in extreme cold, life can organize itself into complex ecosystems in ways we still do not fully understand. The ice shelf was hiding more than water. To understand why this discovery mattered so much, you first have to understand what an ice shelf actually is. An ice shelf is not just sea ice. It is a floating extension of glacial ice attached to the Antarctic continent. The George VI ice shelf, where A84 calved from, is one of the major floating glacier systems on the Antarctic peninsula. These shelves act like lids over ocean water and seafloor regions, cutting them off from normal sunlight, changing circulation, and making direct exploration extremely difficult. When a shelf calves, it does not merely release an iceberg. It can suddenly expose parts of the ocean and seabed that were hidden from ships, cameras, and robots for years, decades, or longer. That means what scientists saw after A84 separated was not just a patch of Antarctic seafloor. It was a place that had been physically sealed off under floating ice. And because those ice-covered environments receive no direct sunlight, the old instinct was to imagine them as biologically poor, harsh, marginal, maybe inhabited by microbes, or scattered invertebrates at best, but not by rich seafloor communities with substantial sessile animals. The discovery after A84 directly challenged that assumption. Schmidt Ocean Institute reported that the newly exposed seabed contained large sponge specimens and other substantial organisms whose size suggested that the community had been active for a long time beneath the shelf. That is an astonishing result because sponges and corals do not become large overnight. If they were there in mature form, then the hidden environment beneath the shelf had been supplying enough food and ecological stability to sustain them over long periods. In a place without sunlight, beneath a floating glacier, that raises immediate scientific questions. Where was the energy coming from? How was food arriving? And how connected was this sealed system to the wider Southern Ocean? The race to reach the newly exposed sea floor. What makes the expedition even more remarkable is how quickly it happened. According to Schmidt Ocean Institute, A84 calved on January 13, 2025. The team aboard the RV Falkor 2 reached the newly exposed seafloor by January 25th and became the first to investigate the area. This was not a leisurely multi-year campaign planned from the start around that exact patch of seabed. It was a scientific pivot, the kind of rapid response that only becomes possible when a research vessel is nearby, equipped, and able to adapt fast enough to a changing polar landscape. That matters because newly exposed Antarctic seafloor is time-sensitive in a scientific sense. The longer a site remains open to changing currents, sediment disturbance, and new ecological interactions, the harder it becomes to infer what conditions were like beneath the shelf before exposure. By getting there quickly, the team captured something close to a first look at a habitat only just released from its icy roof. And what they saw with the ROV Sebastian was not emptiness, but abundance. Imagery released by Schmidt Ocean Institute showed large sponges, anemones, deep-sea corals, and other benthic life covering parts of the seabed. Cambridge's release echoed that description and emphasized that these communities had likely persisted under the ice in isolation from direct surface productivity patterns in ways that are still being investigated. That immediate contrast, expected sterility, observed life, is what transformed the calving event into a scientific revelation. A lost world, but not a dead one. The phrase lost world gets used too loosely in science media, but in this case it is unusually justified. This seafloor was lost in the literal sense that it had been hidden from direct human observation. No diver could reach it. No ordinary ship camera could inspect it through the shelf above. Until the iceberg detached, the ecosystem underneath existed beyond practical access. And yet, once it was exposed, it did not look like a place waiting to be colonized. It looked like a place that had been alive all along. That distinction is everything. If the site had been newly biologically active after exposure, that would be interesting but easier to understand. But a mature under-ice community means the ecosystem was already functioning while sealed beneath the shelf. National Geographic's reporting on the discovery highlighted giant sea spiders, octopuses, and other striking marine life in the newly accessible region, showing that the system was not built from one or two hardy species alone. It was an assemblage, a community, a functioning ecological structure hidden under Antarctic ice. This is exactly the kind of finding that forces science to reevaluate assumptions rather than simply add new data points. Because if substantial communities can persist beneath ice shelves, then under-ice Antarctic ecosystems may be more extensive, more productive, and more ecologically connected than earlier simplified models suggested. That has implications not just for marine ecology, but also for glaciology, biogeochemistry, and even astrobiology. How can life survive under a roof of ice? This was the first big question scientists had to confront. Under a floating ice shelf, there is no direct sunlight hitting the seabed. That means no local photosynthesis in the ordinary shallow water sense. So how can sponges, corals, and other seafloor organisms survive in such a place? The answer is not fully resolved yet, and that is part of what makes this ecosystem so important. But the early scientific framing from Schmidt Ocean Institute and Cambridge suggested that ocean currents may be delivering nutrients and organic material from more open regions into the under-ice environment. In other words, the shelf-covered seabed may be dark, but it is not necessarily cut off from the larger marine food system. Energy can be advected laterally. Marine snow, suspended organic matter, and smaller drifting organisms can still move beneath ice shelves depending on circulation patterns. That possibility changes how we imagine these hidden regions. They are not necessarily sealed biological vaults living only on leftovers. They may be parts of broader ocean systems, linked by moving water, nutrient transport, and perhaps more complex under-ice ecological pathways than we have appreciated before. And if that is true, then Antarctica's floating ice shelves are not just barriers. They are ecological filters, structures that shape flow, darkness, and habitat, while still permitting enough exchange for life to persist below them in surprising forms. The animals were old enough to change the story. One of the most scientifically important details in the early reporting was not simply that organisms were present, but that some were large. Schmidt Ocean Institute specifically pointed to the size of certain sponge specimens and noted that sponges can grow very slowly, sometimes less than 2 centimeters per year. Therefore, a large sponge under the shelf implied not recent colonization, but a long-lived community. Their statement suggested this activity could have persisted for decades, possibly even hundreds of years. This is one of those details that changes a discovery from interesting to profound, because if the community beneath the shelf had persisted for decades or centuries, then that environment was not merely survivable. It was stable enough to support long-term benthic growth. Stability under Antarctic ice, in darkness, with major animals attached to the seafloor, suggests an ecological regime very different from the simple picture of undershelf environments as near-sterile margins. That also means the iceberg did not reveal a freshly forming ecosystem. It revealed a pre-existing one. The life was already there, waiting beneath the ice, long before the outside world knew to ask what might be living under that shelf. What scientists actually saw, the first images from the expedition, were part of what gave the story such force. Rather than a flat, muddy bottom with occasional small life, the ROV encountered structured seabed communities, large sponges, coral-like forms, anemones, mobile animals moving among the sessile ones. National Geographic's coverage emphasized the visual richness of the scene, describing it as a startling kaleidoscope of marine life under the former ice cover. Schmidt Ocean Institute and Cambridge both stressed that the newly exposed seabed held vibrant communities rather than sparse, isolated organisms. That phrase, vibrant communities, matters because it signals scientific confidence that the ecosystem is not being described metaphorically. This was not a press release inflated by one photogenic sponge. Multiple institutions involved in or summarizing the expedition independently highlighted the richness of the site, and that creates a larger implication. There may be many more such ecosystems hidden beneath Antarctic ice shelves, still unobserved, still biologically active, and still absent from our textbooks. The calving itself was a scientific doorway. In climate reporting, iceberg calving is often framed only as a warning sign, and sometimes it is. But from a pure exploration perspective, A84 functioned like a door opening, its separation from the George VI ice shelf exposed a region no one could have inspected directly before. That kind of event creates a temporary opportunity. A place that was once inaccessible becomes reachable, at least for a time, before conditions evolve again. In this case, the iceberg's departure effectively created a new frontier for marine science. That is a strange tension in Antarctic research. Ice shelf loss can be deeply concerning in climate terms, yet the same event can briefly reveal hidden geology or biology that would otherwise remain unknown. Scientists do not celebrate the long-term destabilization of Antarctic ice, but they do recognize that when calving occurs, rare windows into sub-ice worlds can open. A84 was one of those windows, and the team aboard Falkor, too, was in position to act fast enough to look through it. This discovery changed how people think about sub-ice habitats. The old stereotype of Antarctic underice life was already under pressure before A84, but this discovery pushed much harder. Scientists had known from other Antarctic work that life can persist in harsh, dark, and cold environments. But this expedition gave a striking, direct visual example of substantial benthic communities in an area only just uncovered from beneath a major floating glacier. That gives researchers a powerful new case study for how ecosystems function under shelves and what controls their distribution. It also changes public imagination. Before this, a lot of people could still picture the undersides of Antarctic shelves as almost biologically blank. After the images of sponges, corals, anemones, and unusual animals beneath the former ice cover, that mental model becomes much harder to maintain. The under-ice world starts to feel less like an absence and more like a hidden branch of Antarctic ecology. And once you accept that, the continent becomes stranger. Antarctica is no longer just ice on top of sea. It is ice sheltering ecosystems below. Why this matters for the future of Antarctic science. This discovery is not only about one iceberg or one expedition. It matters because it shows what can be gained by pairing rapid response with advanced undersea technology. The combination of timing, ship capability, and ROV access allowed scientists to examine a newly exposed environment almost immediately after calving. That kind of agile exploration is likely to become even more important as polar environments continue changing. It also reveals just how incomplete our knowledge of Antarctica remains. Even with satellites, aircraft, autonomous instruments, and decades of polar science, huge sections of Antarctic marine ecology remain hidden by ice or difficult sea conditions. The A84 event shows that some of the most biologically significant discoveries may still come from places we cannot routinely access. Places that become reachable only when the ice briefly rearranges the map. So the real message is not simply, we found a hidden ecosystem. It is, the hidden ecosystems may be more widespread than we thought, and we've barely started looking. The astrobiology shadow of the discovery. There is another layer to this story that makes it resonate beyond Antarctica. Whenever scientists find life or complex ecosystems in dark environments beneath ice, the comparison to ocean worlds elsewhere in the solar system appears immediately. That is not exaggeration. It is a real scientific instinct. Worlds like Europa and Enceladus are compelling, partly because they are thought to contain water beneath ice. If significant biological communities can persist on Earth in dark, cold, under-ice marine environments, then similar Earth systems become analogs, imperfect but valuable ones, for thinking about how life might survive elsewhere. That does not mean the A84 seafloor ecosystem is a direct model of alien life, but it does reinforce a more general lesson. Darkness under ice does not equal sterility. Life can persist where intuition says it should struggle, and that lesson is exactly what makes Antarctic science so important to planetary science more broadly. The iceberg that broke away from Antarctica did not just reveal a hidden seabed. It revealed how narrow our assumptions about hidden habitats still are.
Antarctica, a continent of mystery and natural wonders. Covered with ice 4 kilometers deep. Temperatures can drop to minus 93 degrees Celsius. 75% of our planet's fresh water is locked up in its ice sheet, and yet it's classified as the largest desert on Earth. This could be the only place in the world where diverse countries have rallied together in the name of peace and science to protect the environment.
The part about the ice and the temperatures, sure, but the part about peace and the environment, it's hard to believe. Not just because I'm concerned about nature, but also because I lived in Syria in 2009. So I don't have much faith left in peace or in the international community. But I'd love to be proven wrong.
We've come to Punta Arenas, where the polar research vessel Esperidas is picking up a group of Spanish scientists to take them to Antarctica.
I'm already nervous.
You'll get used to it. It's no big deal.
Cuidado por aquí que esto está bajo.
It's amazing. I've even got a window.
Bottom bunk?
Last night was rough. We went to bed early, but I had a hard time falling asleep. I must have slept just 4 hours because I was so nervous about the trip.
I embarked on this journey to explore the myths of Antarctica. After one day at sea, we reached the end of the world.
At the southernmost tip of Argentina, Tierra del Fuego is still 1,000 kilometers from the continent of Antarctica. This is the Drake Passage. Eddies and wind churn freely here, whipping up violent seas in one of the Earth's roughest waterways.
The
worst storm to date hit us this year. It was our second trip back from Antarctica. We were about 18 hours from South America when a severe weather system hit us from the starboard side. We faced 7-meter-high waves and winds of up to 50 knots.
Every time the crew sails into the Drake Passage, they have their mobile phones camera ready.
Here comes a monster wave. Could be taller.
These are the outlines of Cape Horn, a notorious maritime graveyard that harbors the sunken wrecks of hundreds of ships. Even today, the Drake Passage commands respect. Everyone battens down the hatches.
It wasn't so dramatic on our trip, though.
Luckily, technology has improved a lot, and today, before setting sail, we can check the weather forecast to find the best window for crossing the Drake Passage.
The adventure may not be as wild as it once was, but it's still beautiful.
Antarctica has been subject to territorial disputes for centuries. The passage was first sailed by Spaniard Francisco de Oces in 1525. 50 years later, it was discovered by the English explorer Sir Francis Drake and bears his name to this day. In the early 20th century, 7 countries laid territorial claims to parts of Antarctica. The overlapping claims of the United Kingdom, Argentina, and Chile caused tensions that erupted into armed conflict between Britain and Argentina in 1952. As the Cold War set in, the last thing the world needed was a new geopolitical flashpoint. It was that realization that gave rise to the Antarctic Treaty.
Many people, including scientists, were looking for ways to cooperate, and there was the International Geophysical Year in 1957-58, and that worked out so well that there was this idea that there could be cooperation in Antarctica. They felt that there was a way, and it's shown in Article 4 of the treaty, to set aside the claims and to say that there would be a demilitarization. But it's also, as you may know, one of the first arms control treaties. So it was focused on keeping the peace in that respect as well.
But none of that was the result of goodwill alone. The extreme climate made it difficult to exploit the region economically, and the US and Soviet Union staked their territorial claims quite late in the game.
Four days after leaving Punta Arenas, the Hesperides reaches Antarctica.
Everyone is excited. We got up at 5 in the morning to catch our first glimpse of the coastline. What we hadn't expected was the fog.
We are 2.5 miles away, and you can't see anything.
A few hours later, the fog lifts, and at last, we can see Antarctica.
The Esperida's first stop is King George Island. The Spanish team is delivering supplies to the Uruguayan station Artigas.
Antarctic cooperation is running smoothly.
The Antarctic Treaty is very effective. Under its terms, this location is devoted solely to science. It's played a key role in getting all countries to set aside their other interests, at least publicly, and it's been that way for a very long time. Unfortunately, the same is not true in other parts of the world, where usually economic interests take precedence over scientific cooperation.
Could this model be exported beyond Antarctica?
That's a good question. It's something many on the planet would support.
Because King George Island offers the easiest access to Antarctica, it has the greatest concentration of stations on the entire continent.
There are facilities here belonging to Uruguay, Russia, Chile, Argentina, Brazil, China, Poland, Peru, Ecuador, the Czech Republic, South Korea, and Bulgaria. The Antarctic Treaty regulates how many new stations can open so that it doesn't get too crowded.
It's always better to coexist peacefully with your neighbors and get along. The first thing we did was to establish good relations with all our neighbors. Cooperation is vital in Antarctica.
When there are tensions between the United States and Russia, does it affect the cooperation in Antarctica?
I wouldn't say there's no effect, but by and large, the cooperation has continued. And it doesn't mean that those tensions aren't, in some respects, in the background somewhere, but at least in terms of the Antarctic programs and the Arctic programs and the work of the scientists together, by and large, that continues.
In 2004, Russia imported wood from Siberian pines, its national tree, to construct a small Orthodox church here in Antarctica.
Critics say it's a sly way to stake a territorial claim. The Chilean station has its own church, too. It also has a school for the children of soldiers stationed on the base year-round. It's the closest thing you'll find to a settlement in Antarctica. In the 1970s, Argentina's military dictatorship sent pregnant women to give birth in Antarctica to underscore its territorial claims. Chilean dictator Augusto Pinochet copied the tactic, but it was widely viewed as provocative. And after the birth of 8 Argentinians and 3 Chileans, both countries ended the policy. Today, more subtle strategies are used to cement territorial claims, as seen on Chilean television.
Easter Island will be overcast with partially cloudy skies, whereas Chilean Antarctica will be mostly sunny.
What do Chileans think about their country's claims to Antarctica?
To be honest, there isn't much public debate on the topic. When I was little, people did talk about it a bit. But later on, the political discourse subsided. Today, people primarily associate it with environmental protection. That's the trend I've observed, especially among young people.
Chileans my age hardly discuss the issue. For us, it's simple. We see Antarctica as a place where many nations come together. There's no reason why we should be more entitled to it than anyone else.
Do you think we can save Antarctica if we fail to do the same in other places?
I think it's exactly because we've made so many mistakes in other places that we have a shot at saving Antarctica.
Spain has 2 stations in Antarctica. Its National Research Center operates the Juan Carlos I station on Livingston Island. It was built in the late 1980s and remodeled in 2008 into a modern facility that looks a bit like a space station.
This station is used in the summer. It doesn't need to withstand the harsh conditions you'd expect to encounter in Antarctica. Today there is hardly any wind, but 2 days ago we had gusts of nearly 40 knots or 80 kilometers an hour, which drives the wind chill factor down to minus 15 or 20 degrees Celsius.
Jerónimo López and his team study the continent's geology, which they say is of essential importance to the rest of the planet.
Antarctica affects the whole world's climate, doesn't it?
It's the planet's cold factory. It's really cold in the Arctic too, but not to the same extent. There's a lot more ice in Antarctica than in the Arctic. Antarctic deep sea water reaches as far as the Iberian Peninsula and continues to circulate around the northern hemisphere. These waters sometimes flow all the way up to the Arctic, where they cool back down again. The motor driving the circulation is Antarctica.
One of the most important projects at the Juan Carlos I station is its study of the Heard and Johnson glaciers.
In recent years, we've evaluated the state of the mass balance of the Antarctic ice sheet and found the gains of ice have been greater than the losses of its thinning glaciers. But next year's data will probably indicate the exact opposite.
So, is it getting colder in Antarctica?
Yes, it is getting colder, but our measurements are limited to the last 15 years. Scientific studies need to examine a period of at least 30 years. If we look closer, we can see that there was a gradual temperature increase for 15 years and a temperature drop in the subsequent 15 years. But globally, the trend is towards warming.
On our trip, we didn't see much snow, but the year before, there was so much snow that the 2-meter-high stakes used to monitor the glacier disappeared. To find them, the Spanish team had to dig. And dig. And dig.
Located next to Livingston Island is Half Moon Island.
We made a discovery in this miniature-sized Antarctica. The weather here changes very suddenly.
Within minutes, the snowfall turns into a blizzard, clocking winds of 80 kilometers an hour. The Esperides' next stop is Deception Island, home to the station Gabriel de Castilla. This island is the caldera of an active volcano. It last erupted in 1970. Huge glaciers are concealed beneath the ash. The Gabriel de Castilla station is run by the Spanish Army.
Wait, Didn't we say the Antarctic Treaty bans all military activity?
Due to the island's difficult terrain and the danger posed by the volcano, it was decided that the Army was best equipped to operate the station. Our mission is to make the visiting scientists feel at home. They come for a very specific time period to work on research, take samples, do experiments, and collect data. Our job is to ensure all the logistics are in place so they can concentrate on their work.
So there are no weapons here?
No, none that I know of.
Deception Island is home to a large colony of chinstrap penguins. Andres Barbosa has been studying these animals for 20 years.
There are species like the Adélie penguin, whose populations have decreased dramatically on the Antarctic Peninsula by about 60%. The chinstrap penguin is also threatened by extinction. But other species, like the Gentoo penguin, have profited from present-day conditions. Its populations have increased by about 15 to 20%. That's basically what's been happening over the course of 4 billion years on our planet. It's called evolution. There are species that thrive under positive conditions, then they vanish and are replaced by others.
Andres installed a camera to monitor the penguins all year long. The images track the birds and their offspring as they gradually flee the onset of colder temperatures. We see seagulls fly by, the drifting icebergs, the arrival of storms that bury the camera in snow and then blow it free again, the long, lonesome winter, the formation of sea ice, sunsets that no one else sees. In October, the penguins return. Soon they begin to lay their eggs. And a few weeks later, chicks are born.
One of the Spanish Navy's tasks is to map the undersea topography around these islands.
Drive it deeper. 086.
Because the Antarctic coast is so immense, less than 1% of the area underwater has been properly mapped. If, for example, you have to change your ship's route because of an iceberg, it can be dangerous to leave the zones for which there are accurate data. So we need to produce more maps to prevent shipwrecks, oil spills, or other accidents. Not just to protect human lives, but also to prevent damage to the environment here. We really have lots of work ahead. It will take years. Every country with the ability to cooperate should pitch in.
The British captain William Smith made the first recorded landing in Antarctica in 1819, an accident after he was blown off course by powerful winds. Spain claims the honor for Gabriel de Castilla, who it says discovered the continent in 1603, though that's never been proven.
It's probable that seal hunters set foot on these islands before William Smith, but they kept quiet about their discovery so as not to have to share its treasure trove of fur.
These are photos of organisms from the Weddell Sea, and nobody knows what family, genus, or species they belong to. They have yet to be classified, which is true of lots of completely different types of animals.
Despite its remote location, far removed from almost all human life on Earth, the Southern Ocean is a vital and precious region of the planet. A team of modern-day explorers has been dispatched to the region by the University of Barcelona.
People thought that because it's so cold, with few resources in terms of food, there would be little fauna on the seabed. But that's not true. Conditions are harsh, but organisms adapt. The ecosystems in Antarctica are the oldest on the planet, so species have had a long time to adapt. And there are species that are in fact unique to the ecosystem here.
Do you feel a bit like explorers?
Well, yeah, I do.
Explorers of Antarctica, today and in times past. In 1911, Norwegian explorer Roald Amundsen of Norway and Britain's Robert Falcon Scott raced to be the first to reach the South Pole. Amundsen triumphed while Scott's team perished trying to return. Though his expedition ended in tragedy, Scott was celebrated as a hero.
On his way back, Scott had picked up a fossil from a tree also found in South America and India. The find supported the theory that the continents were once joined and had drifted apart. So the race to the South Pole contributed to a better understanding of our planet's evolutionary history.
The remnants of an old whaling station can still be found on Deception Island. Long ago, the location was referred to as Red Bay because of the blood-stained water, or Stinking Bay due to the stench of rotting meat and processing oil. It was shut down in 1931. An international ban on commercial whaling came into force in 1986. Japan was allocated a quota for scientific research purposes.
It was long suspected of violating the terms of this quota by pursuing commercial whaling in Antarctica.
We support sustainable use. We like to see whales forever in the future, because that's the only way sustainable utilization is possible. And it is free for any nation to have particular ways of dealing animals in their nation and culture.
In 2014, the International Court of Justice in The Hague ruled against Japan's whaling program.
The court concludes that the special permits granted by Japan for the killing, taking and treating of whales in connection with JARPA 2 are not for purposes of scientific research pursuant to Article 8, Paragraph 1 of the Convention.
Japan complied with the court decision.
But only for 1 year, after which its ships were back out whaling in the Southern Ocean again. Whaling is not the only problem we should be concerned about. The Patagonian toothfish is an Antarctic treasure. It's subject to catch limits, but amid high demand, poaching is a lucrative business.
Poachers ignore quotas and rules on fishing techniques. These mandate the use of long lining, which allows for very selective fishing. But poachers use giant drift nets that indiscriminately kill tons of other fish as well.
In 2014 and 2016, Spanish police, Interpol, and the New Zealand Navy took joint action against Vidal Armadores, a Spanish company accused of illegal fishing.
It was a milestone internationally because Spain issued a public acknowledgement saying, "We admit this is a Spanish pirate fishing company, and we know there are many others."
But this story didn't have a happy ending.
Vidal Armadores appealed a lower court's conviction. The Supreme Court decided in its favour, ruling that the alleged poaching had taken place in international waters, and Spanish courts had no jurisdiction to try the case.
From here, the Hesperides heads south. It sails into the Galash Strait, one of the most spectacular locations on the entire continent. This is the Argentinian station Primavera.
The Primavera station is run by the Army. Unlike other stations, it has a system of raised walkways, so we avoid trampling on fragile plants, including moss and algae, as to cause the least possible damage.
Why is it that international cooperation works here, but not at the UN?
I'm not a foreign policy expert, so I can't say. But the Antarctic Treaty works very well here. If you ask me why, I can't really say. It just does. I wish the rest of the world were this way, but probably there's more egoism in other places.
Is there cooperation between Argentina, Chile, and the United Kingdom, too?
Yes, yes. In fact, I arrived through the Frey station. There's no problem in that respect. Here in Antarctica, it works perfectly. I'd be happy to show you a bit more of the station.
The commander mentioned the Frey station, which is Chilean, but nothing specific about the UK. It may just have been coincidence. Or maybe he was avoiding a sensitive topic. In 1982, Argentina and Britain went to war over the Falkland Islands. For many, it left wounds that never healed. For days, we watched otherworldly scenes unfold before our eyes. During those weeks, we discovered Antarctica's infinite beauty and one of its biggest threats.
We saw record visitor numbers in 2008-2009 with some 46,000 tourists. The financial crisis hit the tourism industry and numbers dropped to below 25,000. But recently they were back up again to 46,000.
What if the numbers keep rising?
We don't know what will happen. I think numbers will increase, but these trips aren't cheap. They cost between 5,000 and 10,000 euros per trip. Not a lot of people can afford such luxury.
For every researcher in Antarctica, there are now 10 tourists. It's a business that rakes in some 400 million euros per year.
A few years ago, an NGO opened a museum here inside a British station dating from the 1950s.
There are rules of conduct for visitors, but more needs to be done. It would help if tourists were required to make a monetary contribution to regional conservation. Currently, only 10 of the 5,000 to 10,000 euros they pay for their trip go toward erasing their footprint, but none goes to conservation management. Often it's the tourists themselves who file complaints against the tour operators who flout regulations.
Do you think tourism may have a negative impact in Antarctica?
Personally, you know, we were able to have a lot of time to walk and trek and then spend a lot of time walking around the islands. And so far we've found some trash, which is very surprising in a way because, you know, in our mind, or at least in my mind, I thought Antarctica would be a very pristine and remote location, would be untouched. But then looking at, you know, a milk carton from China, and I'm Chinese, I can read that, and then looking at different water bottles and waste on beaches, and it's shocking in a way.
It's not just tourism. Any human presence in Antarctica can pose a threat.
We're looking for aliens. Aliens in the sense of species that didn't exist in the region before. They arrive, check out the local conditions, and if they meet their ecological requirements, they settle and propagate. We want to identify the invasive species that have displaced local populations.
If the temperature rises even slightly, species that would previously have been unable to survive or propagate can invade and occupy the habitats of native species and supplant them.
How do these invasive species reach Antarctica?
They arrive through different natural channels, either on the wind, by sea, or tree trunks, or other floating objects, or on animals. But natural routes aren't the main source of invasion. It's us humans who inadvertently carry them here on vehicle wheels or our shoes. Many species die in the harsh conditions, but other more hardy ones become invasive.
That's why we were required by the Spanish Polar Committee to carefully vacuum each one of the items we took with us to Antarctica. Can you solve this problem alone?
No, but the great thing about Antarctica is the cooperation between the many countries active here. A good example is our success in eradicating an invasive species 2 years ago. It was a coordinated effort of the Spanish, British, and Argentine polar committees. And that despite the fact that Britain and Argentina have a history of conflict in the region. We eradicated the invasive species. We ecologists are the Earth's doctors, and we've diagnosed a disease. Now the onus is on society to follow the doctor's orders.
After a week on the Galáš Strait, the Hesperides makes its way back to the Spanish station. From there, it will return home.
But I couldn't leave Antarctica without investigating the world's single biggest threat to peace and the environment.
Without a doubt, there are mineral resources in Antarctica, and there's oil.
And there are not just hydrocarbons in the form of natural gas and petroleum, but also minerals like nickel, gold, and silver. Some recent publications even report findings of a type of rock that may harbor diamonds.
It's become increasingly easier and cheaper to reach Antarctica. There could be minerals here with a value so great it might justify their exploitation, even in such a remote location and hostile environment.
I witnessed the Prestige oil spill firsthand. We conducted research to determine the spill's impact along the entire coast of northern Spain, and the findings were devastating.
Oil isn't just hard to remove, it's impossible. We take off the upper layer, but the rest stays stuck.
An oil spill in Antarctica on the scale of the Prestige would be a total, utter catastrophe. The oil's impact on the ice sheet would be far more dramatic than any of the effects it can have in other regions.
Why?
First of all, because it would be impossible to reach all of the affected areas. And secondly, when it freezes, the oil gets trapped inside the ice. So it would be much harder for marine currents to disperse the oil into other areas.
In 1989, signatories of the Antarctic Treaty were poised to open the door to limited oil and mineral prospecting. That had new countries lining up to join the club.
But then, once again, a miracle happened.
Today saw the signing of the Madrid Protocol. The agreement aims to protect the environment of Antarctica, the only remaining pristine territory on our planet. It's set to stay in force for the next 50 years.
As so often, the world's most powerful countries were divided. A row erupted between the more environmentally conscious, mostly European nations, and the United States, Soviet Union, China, and Britain.
In the end, all agreed to a 50-year moratorium on the exploitation of mineral resources. The ban can only be lifted with the unanimous agreement of all signatories, which is virtually impossible.
The protocol was a compromise between the interests of two sides. It banned the exploitation of resources that could cause severe pollution and irreparable damage to Antarctica, but it failed to impose a permanent ban.
The Madrid Protocol will be subject to review in 2048. What happens then?
Achieving consensus on anything is a very hard thing to do. So as long as you haven't convinced all of the countries that a change from current policy is needed, then the current ban on mining continues as a legal matter.
That may be, but some are still tempted. In 2007, Britain asserted new claims to a vast area of the seabed off Antarctica.
There's a reason why countries go to great lengths, shipping resources and people to open stations in Antarctica. They want to ensure they'll be there when the continent is divvied up, even if no one will say so publicly.
As a researcher, do you feel you're being exploited for that end?
No, not at all. I have always believed it's better to join forces with your enemy, to take advantage of all their resources. If through our research we can obtain data that will help protect Antarctica, I believe that's our best option.
And so, the Spanish researchers and military personnel take leave of the southernmost continent.
Shortly before we reach the mainland, we receive footage of the penguin colony on Deception Island.
The chicks were born 20 days ago. The embryo in this egg is dead. Its parents can't lay another until next year. It's hard for them to let it go. Humankind also tries desperately to protect the things it loves. And science has shown that the human heart is bigger than that of a penguin. Or would you beg to differ?
No, that's the one thing we can agree on.